Hello, my name is Richard Halter, and this little presentation is introduce you to something called POSLog. And POSLog is the lifeblood of retail, as it provides information to virtually every system in retail for them to be able to make their management decisions. This is the agenda for today's presentation. I'm not going to spend a lot of time going through this, as you will see it as we work through it, but just gives you an idea of the overall areas that are covered in this POSLog, the lifeblood of retail. So who am I? I am the Wizard of POS. In the course on POSLog, you're going to learn from one of the primary authors of POSLog. That's me, Richard Halter. I was the chair of the POSLog committee when we first published our standard, and at the time I was working for a small company called McDonald's. And in the last 20 years, I've helped write all 34 message models with multiple versions for communication. For example, POSLog is in version 6 now. I helped create 20 RFP templates to help people buy applications in retail. There are 9 blueprints, which are documents explaining the information necessary to create the message models. There are numerous design models in here. There are architecture designs, task state drawings, data flow diagrams, etc. There's a very large number of these things showing how to put all of these things together to create an application. On top of that, there are 45 devices, and these are devices that like interface to a printer, for example. And the latest group of these are a set of robot interfaces to be able to control robots. There are 7 integration papers where they didn't lead to standards, and these are very much similar to blueprints, except they're telling you how to use other standards. Then there are 9 best practices papers. You can't have a standards organization that doesn't have best practices to tell them how to build things. And there is one operational data model, and this is where the Retail Technology Standards Group started in 1994. And today there are over 800 tables in this model, and there are over 8,000 attributes, and it covers virtually everything in retail. During my time as a chief technology architect, I was the man behind the curtain. I was the person that created all of the magic that you will see. And as such, I was given the title Wizard of POS. We're going to start this journey by looking at the evolution of the point of sale itself. Way back in the 1800s, the point of sale started out as a simple cash box. They simply took a cigar box and put the money in it under the counter. As you guess, accountability and theft was large. So in 1879, one of the first cash registers was invented. This is actually a picture of one that my boss had in his office. That was a manual cash register. You had to enter it and push all the buttons yourself. And then eventually, in 1906, it was NCR created the first electronic cash register. Then in 1973, IBM created a point of sale. It was now able to connect to other systems and report its information to the central part for tracking. Then in 2010, I was the architect for the first omni-channel point of sale system. That system was so successful, NCR bought it, and it's now called the Emerald point of sale system. It was the first time that they was able to natively have somebody buy online and pick up in the store, add new things to the register, and then finish the sale on a different point of sale terminal. And now we are in the modern unified commerce world. As you see in this view of the modern POS, there are a lot of engines that you must integrate with in the unified commerce world. These engines are just the sell item in today's modern agile architecture, and they can be anywhere in the cloud. Once you've sold something, you need to communicate this information generated by all these engines to the rest of the retail world. And that's where POSLog comes into play.
It is now the lifeblood of retail. To simplify the complexity of integrating with all of these applications located in different clouds all over the world, you have to communicate to all of these applications with one message format. And how do you communicate all this POS information to all these various systems, applications, and devices? This is POSLog. Again, the lifeblood of retail.
So what is in POSLog? Well, POSLog is a message model, and as such, it has to be able to encompass a very large amount of information. While each message that is sent is a very small subset of the overall message. For example, the overall message has got 7,000 plus elements and attributes in it. And it's there to support multiple technology architectures, like a monolithic architecture, which is the traditional model, or the new microservices model, or even the older WSDL model. It has business processes embedded in it, so it does the biggest part is traditional sales and returns, but it supports online ordering. It supports the buy online, pick up in the store model. There are many communications models that can communicate this POSLog information, request response, event models, asynchronous models, and synchronous models. As we focus in on the point of sale, we see that POSLog is the information that is the lifeblood of most of these applications for them to make decisions on what they're going to be doing.
During the day, the POS provides these major categories of information. First is what everyone expects. It's normal transactional data. In addition, there's a host of non-transactional financial information, such as money is taken out of the till to pay a window washer, when money is taken in from a newspaper vendor. This type of POSLog transaction is called a tender control transaction. The third major set, it deals with real-time events, such as store operations or loss prevention, to support timely decision-making. And additionally, POS supports hypermarkets. So it has things like an inventory control, tracking inventory coming into or out of the store, transferring between stores. Or it deals with forecourt, fueling kind of information. And finally, it deals with the special unique attributes of the food service world. This is a block diagram of the POSLog sales transaction, starting out with the common header. This common header is true for all of the transaction types, whether you're doing sales transaction or you're doing tender control transactions. They all use the same common header information, and you'll see the details later. And the next step down is the sales transaction types, starting with the retail transaction, which is a transaction that has been both tendered and delivered. It has a customer order transaction, which allows the customer to order a transaction that hasn't been tendered and or delivered to the customer. So you can record it if transactions in process. The difference between this and the retail transaction is basically the retail transaction is when you can now consider it for profit. And then there's an order transaction, which you start by building a transaction on the web by just selecting things on the website without doing anything more than just selecting them. So you build up this order transaction. But when you finally decide you want to buy it, it moves to a customer order transaction, at which point you can pay for it and then have it delivered. And then when it finally gets delivered, it becomes the retail transaction. And then here are the various line item types that are available in the POSLog sales transaction. We'll go into more of the details of this later. And then here is the item information. It's common items. An item is the thing you're trying to sell, be it a service or a product, if you will. And then finally, you have the tender information, all of the various tender type information, everything from paying with cash to paying with a credit card. And now we get into the scary part. This is the domain model of just the retail transaction component. As you can see, there is a huge amount of information that can be fed from a point of sale to all of the various applications that need just the retail transaction component. The other page has things like the food service, the forecourt. It has the tendering and the control transaction components. It's a very large model that covers virtually everything you can do with retail. Retail is complicated, so let's explore some of the complexities that POSLog helps solve. So what is a retail item? The POSLog supports a lot of different environments, starting on the left with the food service world. It goes into the retail world where you can buy a shirt. It supports the forecourt world where you can buy gasoline. It could even support building a battleship because it's just an item. All of these are simply an item, a price, and a quantity. What's interesting is this information hasn't changed since the Stone Age. Back then, you had items, you had prices for it, and you had quantities, just like today. This is a picture of a hand-wired computer backplane that I worked on back in the 1970s. As you can see, it's a confusing mess. Changes and upgrades were a major challenge. And in the retail world, this is the same thing. This is a traditional retail integration model. I created this model and we started way back in 2000. As you can see, it looks almost as bad as that previous slide. Then in the 1980s, IBM came up with this standardized computer backplane, and it dramatically changed the entire technology world. And that led eventually to this retail service model, where you had all of these various services that could be located anywhere and plugged into the backplane so that they can communicate with each other. And you can imagine trying to connect these things up through that messy model that we just looked at. 5 retailers in 1993 got together to try to solve that integration problem for just the data model. They were very much tired of buying new systems and having to update their data model because of the weird mess that the new data model created. And that's where ARTS came in. In over 25 years, along with 1,600 subject matter experts, I helped create this extensive library of ARTS work. In totals, these represent somewhere between 15,000 and 20,000 attributes and elements and cover somewhere around 85 to 90% of all of the information in retail. And I've trained this work to retailers and vendors all over the world. The number of stores represented by this training exceeds 100,000 retail stores. This work is overwhelming. So let's take a quick look at the various checkout models. So we start with the traditional checkout model. You put the stuff into a shopping cart, you go to a checkout stand, you put it in your car, and you go home. The food service checkout model, the drive-through model, created a new problem. You went to one speaker, you ordered your items, you went to the next one, you paid for your items, and you went to the third one to pick up your items. And that created some new ideas in managing the point of sale transaction. Then along came the web model, where you would go to a website, you'd pick out the item you wanted, you'd pay for it on the website, and then you would have it delivered to the house. And now you've got to be able to communicate this information over a wide time frame in order to solve what a retail transaction looks like. And now we're starting to see things like the shopping cart point of sale, where you take your items with RFID tags on them, you put them into your shopping cart, it automatically records what's there. You go through the checkout stand, and all you have to do is give them your credit card information, and then take those items home. It speeds up one of the bottlenecks, which is the checkout system. And now we're in a new customer-driven world where they want one experience, no matter which channel. They want to be able to go to catalogs. They want to be able to go to a web. They want to be able to go in store. You want to do mobile, you want to call it in and have you deliver it. There's all kinds of different things, and they all want one seamless model, which is what POSLog provides the retailer. Now let's look at the future of POS. And of course, the future is now you can start in your home, where you can start putting together what you need in the kitchen and put it onto your shopping list. And this sample, that shopping list is created on a wall-mounted point-of-sale system. This starts, and now we have IoT devices that expands that journey. Your air conditioning unit can say you need to buy a new filter. Your refrigerator can say you need to add eggs. Your washing machine can say we need more salt, more soap. And you can use your mobile device for adding and removing items to your shopping list. Your shopping list is then sent off to the store, to the various retailers for them to fulfill those items that you need. So that now brings us to the unified commerce in an agile world system.
The modern Agile microservice technical architecture breaks the traditional retail processes into separate, smaller components. This allows real-time, dynamic, seamless upgrades. Because of the potential number of interactive components in the unified commerce world, microservices becomes a key part of a complete unified commerce system. So what does a unified commerce process look like? We're going to use this buy online, pick up in the store example to show you how to use this model. It starts with an IoT device, your refrigerator, in your home that has found you are low on eggs. So it adds eggs to your shopping list. You can add other things from a kiosk, a browser, a mobile phone. Then you can use social media to approve your items before you buy them. When you're ready, you can have the shopping list sent to the store. The store receives the list and has to develop a path for the robot to go pick up these eggs. That path depends on what items are in inventory, what's the store layout, where are the customer preferences, what kind of eggs do they like to buy. And once the path is built, it's sent to the robot to drive around picking up the items and putting them in the cart. When it has what your shopping list wants, it then moves on to being paid for the items. At that time, the payment moves to the payment processing system, which sends money to the bank. It gets authorization from the bank, and it splits off the sales tax and use tax to be sent off to the treasury. Once the items are paid for, you have to figure out how to deliver them, how the customer wants them delivered. You either send the package to a drone for delivery with a drone, or you split them off and send them to a self-driving car, in which case you have to know where it is. If the customer has a self-driving automobile, it is somewhere in the parking lot, and you have to find it to put the items in it. It then either gets delivered to the home through the self-driving automobile or through a drone delivery automobile.
So you're hearing today that all you have to do is use an API, and that solves that whole integration problem. They're going to see why that's misleading. See, the API components contain two pieces. One is the connection methodology, and the other is the payload, basically the information. POSLog provides that information component. So, for example, here's the sample REST API commands that are used to interact with your various resources, starting with a GET to retrieve data from the server, a POST to send data to a server, a PUT to update the existing resource, a DELETE to remove a resource from the service. With these commands, you can perform a CRUD, a read, update, read, and delete operations in a RESTful API. If you notice what's missing, Now, one of these is about the information components. So now let's look at the information component. That's what POSLog provides in a standardized format. As you can see, no API out there actually has POSLog kind of details that you can easily communicate to all of the applications that need this information. Now let's take a look at what the retailers were trying to solve way back in 1993. They were starting with the ontology misconnection. One system may call something a product, and another one may call it an item. How do you know those two are the same thing? And in both systems may call it an item, but one of them may put the message at the top level of its message, and the other may put the item at a lower level. So now you have to solve that problem. And both require some sort of translation engine. The true standard message model calls it one thing, has it in the same level, and avoids misunderstanding. Now imagine this problem with over 7,000 POSLog attributes. That is a massive problem just to connect two systems. And imagine you've got 40 or 50 systems in your retail environment, and that message is insane.
Thank you. I am the Wizard of Pod. My name is Richard Halter. Please check out my book, Art for Retail, Using Technology to Turn Your Consumers into Customers and Make a Profit. It's available on Kindle. Thank you.